Here's another example. Archimedes probably knew this one, but I'm not sure that he did. He didn't have quite the algebra that we do today, so this is going to be a little easier than what he would have had to do. But show the surface area of a sphere of radius c is 4 times pi times c squared. And we'll have to find, what we're going to do, we're going to find the upper hemisphere and then double it, so that'll give us the entire sphere. So first of all, the equation for that sphere would be x squared plus y squared plus z squared equals c squared. That's a sphere of radius c. So z, or f of xy, is the square root of c squared minus x squared minus y squared. R would be the inside of the circle, where x squared plus y squared equals c squared. And so our partial derivative of this function with respect to x is going to be this to the negative 1/2 times the derivative of the inside function, which is negative 2x, and the negative 2 and that half in the denominator should cancel each other out, so you see why that would be fx. Similarly, you should see why fy, or the partial derivative with respect to y, is this. And now the fun part. This is our integral, unfortunately, and it doesn't get any better than this. Well, actually it does. Be patient, okay? If you notice, this is square root of c squared plus, well, when I square this, I just get c squared minus x squared minus y squared in both of these. And of course I get positive x squared and positive y squared. And then when I make a common denominator with this 1, I get c squared plus, or minus x squared minus y squared over itself. And then that plus x squared, or minus x squared, and the plus x squared I get from squaring this, and this plus y squared I get from squaring that cancel out, and I just get c squared in the top. The denominator, of course, is the thing I have there and I expected. But remember, it's been squared, so it's not under this radical, it's under this radical. Right? So hopefully you're good with that and can understand why it's that. Of course, a few things to note. Square root of c squared is just c, so now that became a little bit simpler. But as you can see, this is a bear to try to integrate that with respect to y. Some horrible trig function with arc sine might in fact work, but I'm not going to bother with that. I'm going to say, well, this integral deserves to be in polar coordinates. And so this describes our region. The limits 0 to c, remember the area, the radius of that circle was c, so that's the r limits, and the theta limits, theta going from 0 to 2 pi, that describes a pretty good circle. And so instead of x squared minus y squared here, or x squared plus y squared, we replace that with r squared, and the dA, dy dx is replaced with r d theta. And lo and behold, if you make the u substitution, u equals c squared minus r squared, then du is negative 2r dr, and things come out pretty nice. We have, now here's a little tricky part. If r is going from 0 to c, then u would be going, when r is 0, u is c squared. When r is 0, or I'm sorry, when r is c, u is 0. And the other thing is, since this negative 2r dr, we'll have a negative 2 in the denominator with the c over the square root of u. Now, call it u to the negative 1/2 if you'd like. But I can factor out this negative and switch these two limits of integration around. And I get something that looks a little nicer. C over 2 square roots of u du d theta. Integrating with respect to u, keep in mind that's u to the negative 1/2, so add 1 to that, you get u to the positive 1/2, in other words, square root of u, and then divided by 1/2, which is multiplied by 2, which cancels this out. So we get c times the square root of u going from 0 to c squared. When I put in 0, of course it's an obvious one, when I put in c squared for the square root of u, I get c squared. Times going from 0 to 2 pi with theta, well, put in 0, you get 0, so we get 2 pi times c squared. Keep in mind, we should be getting 4 pi c squared, but what you maybe have forgotten by now is, oh yeah, This was only the upper part of the sphere. So if we double that, we get 4 pi c squared, which is what we wanted to show.